Have you ever been on a plane, taxiing to the runway, and just looked out the window at that incredible maze of lines, numbers, and signs? It really does look like chaos. But it's not. It's actually a super carefully designed language. Every single one of those markings, every light, has a very specific job, all working together for one single reason: to keep everyone safe.
Yeah, from a pilot seat, this isn't just some complicated view. It's basically a page of instructions, a roadmap, and a rulebook all rolled into one. It is the language of safety and precision, and today, we're going to learn how to speak it. So, here's how we're going to break it down. We'll start big picture with the airport ecosystem, then figure out who's calling the shots. After that, we'll get into the nitty-gritty of decoding all the paint on the ground, and we'll wrap it up by learning the language of lights.
Okay, so first things first. We have to establish what we're even talking about when we say airport. Because trust me, that word covers a lot more ground than you probably think.
The official definition is, well, it's incredibly broad. An airport is simply any area, whether it's land or water, that's meant for planes to take off or land. That means a massive international hub, like JFK or LAX, and a tiny little grass strip in the middle of a field are technically both airports. Now, here in the US, we break them down into a few main types. You've got your commercial service airports. That's where most of us fly from. Then there are cargo airports, the giant hubs for places like FedEx. Reliever airports are smaller fields built to take some of the pressure off the big commercial ones. And then you have general aviation. This is the biggest group by a long shot, covering thousands of airports for everything from flight schools to private planes.
All right, so no matter how big or small an airport is, it operates under one of two fundamental systems. This is maybe the most important distinction in how an airport works, and it all comes down to one simple question. Is there a control tower?
At a towered airport, it's pretty simple. Air traffic control, or ATC, is the boss, period. Pilots have to be in constant radio contact, and they have to follow every single instruction they're given. But at a non-towered airport, things get really interesting. Pilots actually coordinate everything among themselves. They all tune into the same radio frequency, the CTF, and announce what they're doing and where they are. It's this incredible self-regulating system that completely relies on everybody following the rules. And this is exactly how it works. To make sure there isn't total chaos, pilots flying into these non-towered fields follow really specific, standardized traffic patterns. Everyone enters the pattern the same way. They fly at the same altitude, and they constantly talk about their position. It creates a predictable, orderly flow, even when there's no central controller watching over everything. Okay, now for the really fun part. Let's get down on the ground and actually start decoding all those markings. This is where the airport really starts speaking directly to the pilots. Let's start with the biggest marking out there, the runway number. What's so cool about these is that they're not random at all. They're actually shorthand for a compass heading. You just take the magnetic heading, round it to the nearest 10 degrees, and drop the last zero. So a runway labeled 36 points to 360 degrees, due north. Runway 09 points to 90 degrees, due east. It's such a simple but brilliant system that instantly tells a pilot which way they're pointing. All right, out of all the signs on an airfield, this one is, without a doubt, the most critical. You'll see at any place a taxiway is about to cross a runway. And that bright red background isn't just for looks, it's a universal signal to stop and pay very close attention. Let me put it as simply as I can. This is the airport's absolute, non-negotiable stop sign. The red and white design taps into that universal visual language for danger and halt. It's made to grab your attention. You do not, under any circumstances, pass this sign without getting explicit clearance. It is the very last line of defense. And that sign doesn't work alone. It's always paired with these very specific markings painted right on the pavement. You'll see two solid yellow lines and two dashed yellow lines. They mean the exact same thing as the sign. And there's a really simple rule pilots live by to read these lines. If the solid lines are on your side, you have to stop. But if you're coming from the other direction and see the dashed lines first, which happens when you're leaving a runway, you're clear to cross. Solid means stop, dashed means you can pass. It's that simple. Now, as you're moving along the taxiways, you'll see these yellow signs everywhere. The easiest way to think of them is like the airport's street signs. The letter tells you what taxiway you're on, and the arrows point you towards other taxiways. It's basically a GPS system built out of metal and paint, guiding these massive machines around with perfect clarity. But what happens when the sun goes down? Well, this language doesn't just disappear. In fact, you could argue it becomes even
more important. At night, or in bad weather, pilots read the airport by its lights. From miles away, a pilot can tell exactly what kind of airport they're looking at just by the color of its rotating beacon. A flash of white and green, that's your standard civilian airport. White and yellow tells you it's a seaplane base. Throw a green in with the white and yellow and you've found a heliport. And if you see two quick white flashes and then a green, you're looking at a military airfield. Now, as a pilot gets ready to land, they need to stay on a perfect descent angle, what's called a glide path. To help them out, a lot of runways have a lighting system called a VASI, that's short for Visual Approach Slope Indicator. It's an absolutely brilliant system that gives pilots instant, easy-to-read feedback using just two colors. The VASI usually has two sets of lights, and pilots have this great little rhyme to remember it. Red over white, you're all right. That means you're right on the glide path. If you see two white lights, the saying is white over white, you'll fly all night, meaning you're too high. And two red lights, red over red, you're dead. You're way too low. It gives you an instant visual check. You might also see a system that looks like this. It's called a PAPI, a Precision Approach Path Indicator. It does the exact same job as a VSI, just with a single row of 4 lights. The idea is identical. The mix of red and white lights tells you if you're high, low, or perfectly on track. 2 red and 2 white is the sweet spot. But what about the ultimate what-if scenario? What if a plane's radios just totally die? Well, guess what? There's a language for that too. It's a last resort, but controllers in the tower can use a high-powered light gun to send signals. A steady green light means you're cleared to land or take off. A flashing red is a serious warning. Get off the runway. Or don't land because it's unsafe. It's this century-old backup plan that just shows how deep these safety systems really go. So the next time you find yourself at an airport, look a little closer. You'll start to see that it's not just a bunch of concrete and buildings. It's a living, breathing language of safety, spoken in paint and signs and light. A language that you now know how to read. And it kind of makes you wonder, right? What other hidden systems that we rely on every single day are just out there, waiting for us to decode?